Hey everyone, welcome back to Programming with Mike. In today's video, we're going to talk about variables in C, primitive data types, their memory sizes, and their minimum and maximum values. What is a variable in C? A variable in C is a container that stores data. Before we can use that variable, we must declare its type. The type determines how much memory it takes and what kind of values it can store. C provides several primitive data types, which are fundamental building blocks of all programs. Let's go over them one by one. So, in VS Code, we can start off by including the stdio function, which gives us access to the printf function, the limits.h, which gives us access to the macros that define the maximum and minimum values of each primitive type, and the floating.h, which does the same thing as limits.h but for float variables. We are going to start off with integers, which stores whole numbers, meaning numbers without decimals. C has multiple integer types based on how much memory they use and the range of numbers they can store. The most basic one is the int, which can hold an integer which has a size in memory of 4 bytes. We can declare a variable by stating the type of that variable, in this case int, its name, my int, and its value, 42 in this case. If we compile our program and see the output of this program, we will understand better the size, the minimum and the maximum values of an integer. So go ahead and open a terminal and compile our program with gcc, the name of our C file, which in this case is primitive types .c -o, and the name of the executable. We can call it out. As you can see, the executable was created successfully. We can run it by typing this, and we can see that our integer has a value of 42, which is correct, has a size of 4 bytes in memory, and this is the minimum and maximum values it can hold. Next up, we have the short, which uses less memory, usually 2 bytes. It's smaller and thus holds smaller values. If you go ahead and compile this program now and run it, we can see that the short only uses 2 bytes and can hold much smaller numbers. Going into the bigger numbers, if we want to represent bigger numbers than this, we have the long. It has 8 bytes and thus can hold bigger values. So if you compile our program, we can see that it has 8 bytes and can hold much larger numbers. Now, floating point numbers. Floating point types store numbers with decimals. These are used for calculations that require more precision, such as scientific computing and graphics. Floats can hold numbers with decimal points. The most basic type is the float, which can be printed by putting in the printf function the %f and print a float number. In this case, if we compile our program, we can see that a float type is 4 bytes long and can hold these numbers in the maximum and minimum. If we want more floating time precision, we have the double type, which, as before, the integer and the long, now the double has double the size of the float and thus can hold even bigger floating type numbers. If we compile our program again, we can see that the double holds 8 bytes in memory and thus can hold even bigger numbers than the floating type. If we want to go even bigger in floating type, we have the long double, which has an extended precision, in this case, of 16 bytes. If we run the program, compile it again and run it, we can see that the long double has a size of 16 bytes and can hold much larger numbers with decimal points. Last but not least, we have the char. The char type is used to store a single character, such a letter or a symbol, and it only takes up 1 byte. It basically can hold every character on your keyboard. If we run the program for one last time, compile it and run it, we can see that the char has only a size of 1 byte and has a minimum value of minus 128 and a maximum value of 127. These numbers correspond to one character in the ACSHI table. So, that's it for today. If you want to try it out, copy the code and try it out for yourself by replacing these values and trying to figure out how the printf function works better. Thank you for tuning in. Now you know how to declare variables, understand primitive data types, check their memory sizes, and even see the minimum and maximum values in C. See you next time.